In this short video, I show how we can start with a raw aggregate obtained from Phon and distill that aggregate into a smaller set of patterns that we can then use to generate a graph for data visualization. So here is our raw data obtained from Phon, and in the context of the tutorial is the data that represents Katochia's productions of D in singleton nonces across the data set. And so we can see the different ages on top and the different patterns of D production on the left. So D produced as D, we'll call that an accurate production. D aligned with nothing, which is a deletion. D aligned with T, that would be a case of devoicing. And then we have a series of other patterns. And what matters here is that these other patterns are not represented really robustly across the data set. And even the voicing itself is, borderline a marginal pattern. So what we want to do is take this raw data, and I've given you a few observations about it, and get this organized such that someone looking at your chart or your organized data would have a very quick reading of what are the driving patterns or the most prominent patterns in this data set. So one of the first things to do is to look at how every line, so how every pattern represented on each line is prominent relative to the other patterns. And one trick one method to have a good sense of that is to just look at how many examples are present on every line by doing a sum. So equals sum open parenthesis of the entire data set on this line. So you drag your mouse, and then you have the sum of the line here is 266. So if I do it again, I click on the cell where I want my sum, I do equal sum, open my parenthesis, and then click and drag across my range. So, and here my range is for only one line, and then I hit enter and I get my sum. So once you've done a formula, you can always expand it by selecting one cell that contains the formula and click on the bottom right corner of it and then drag across the whole range. And this will map that formula to the other lines. So if you look at this, it's the sum from C2 to R2. On the next line is the sum from C3 to R3 and so on. So here C4 to R4 and so on. And then what we can do is sort our data by what would be column T. Sort our data in a descending way by column T. And here that gives us the patterns by order of prominence. And the reason why my patterns were all sorted now is that I had done this work before and forgot to reset my sheet to the original, but that gives you still the same idea. And I will put another sum here, equals sum of my entire table. And as you can see, I've done my sum over the entire table as opposed to do a sum of my sums here. And the reason is that I will use this last sum 513 as my checksum to make sure that when I have my distilled aggregate also contains 513 examples. So as I mentioned earlier, we have a pattern of accurate production. We have a pattern of deletion. We have a pattern of devoicing. And these are my top three patterns. And from there, there's a series of marginal patterns. If we wanted to have the pattern of D produced as L, lateralization, we would add this. We could call it lateralization. But here, given the low number of L productions, and given that most of these numbers are produced in a small part of my data set, I will for now consider this to be a marginal pattern. Someone interested in this pattern could go back to the data and try and see if there's something phonological behind them, but that's going to be a question for different research. For the time being, what I'll do is group all of my other patterns in the other category. So these are the 4 categories that I want represented in my graph, and the categories will be mapped longitudinally using the same dates. So all I'm doing here is I copy and paste my session ages. I said dates, but it's really ages. So these are the ages at which Katotia produced all of these patterns. And all I'm missing now is the sum of the relevant numbers to show up in my aggregate. So I can start with the first one. So the accurate production in this particular case is found only in one cell. So I can do equal and click on the cell that contains the number. So equal C2. Deletion would be equal C3. Devoicing will be equal C4. And the other category will be equal, and here I could do C5 plus 6 plus 7 plus 8 and so on, or use the sum function that I used to produce my my numbers on the right hand side of my chart. So I could do equal sum, because all of my marginal patterns now are grouped within the same range, because they are the patterns that are low in numbers. And so by sorting my data earlier, my aggregate on top, I ended up putting all of these patterns at the bottom there. Other analyses could use different methods. So for example, a researcher here could say that I'm not interested in voicing because voicing in Dutch is a little bit variable. So what I will do here is consider that my D produced as T is also an accurate production, and I will not look into devoicing. So the researcher doing that could just not have a line for devoicing, so I will delete my row. And when it comes to accurate productions, we could say that the accurate productions would be a combination of C2 plus C4. And that choice of merging 2 productions here within one category, or merging a series of different productions into a larger, marginal category, is really left to the person doing the research. Because we sometimes pursue different methods because we're interested in different research questions or different criteria to describe our data. So here, what I will do is just undo my work and get back to devoicing. But I did want to talk about this to give you a sense that there are different options, and that by using the plus function within Phon, then we can add different results from the top table into the bottom table. And now that I've done this for my 4 categories, what I can do is select my formula. So select the cells that contain this formula and expand them across the range. And that will give me the sum of other productions, the sum of devoicing, and so on. And in this particular case, because the top 3 category correspond to 3 lines, of course the numbers should map perfectly. But if we had pursued another research whereby the sum of the accurate productions and the devoiced production would be added, then the accurate production line here would contain the sum of the lines from the second and the fourth line. So I've done my aggregate. Sometimes it's easy. This is an easy one. Sometimes it's a bit more tricky. So it's always safe at the end of it to do a sum of the whole aggregate, the new one, the distilled aggregate. So I do a sum and I map the whole range. And here I get 513 examples, which means that all of the examples contained in my raw data on top are now represented in my chart at the bottom, which means my aggregate was done without dropping examples. And once I've built that aggregate, it becomes very easy to generate a chart. So in LibreOffice Calc, you can go by selecting the range that contains your column and line labels, including the data. Go in the menu Insert, chart. And here comes the wizard. This is how LibreOffice works. I like to work with stacked column charts. So I'm choosing my stacked chart, hit next. The data series are in rows, they're not in columns. So we can change that, and already we can see the data set take shape. The next step consists of ordering the patterns in their legend. Here you can see that the chart starts with the other category, which is the thing I want to not emphasize. So what I will do is select every bit, and you'll see something interesting there, that for my category to be on top in the chart ends up being at the bottom here in the wizard, and both LibreOffice and Excel do that in the way that they enable you to reorder your items. This is just a quirk of these programs, but what you can do is play with that and always keeping an eye on the end result. And what you can see here in the end result, where everything is organized, is that you have your accurate productions on top, followed by your deletions, followed by the devoiced Ds, and finally the other category. And you can see that across the whole data set, my other categories, sometimes they compound, they become a bit more prominent. But if you look at the entire data set, then really what stands out are two facts. One of them is that the child is producing a fair number of accurate Ds across the data set, or almost all of it. But in parallel to that, she's also producing a fair number of deletions. So that's something that can be interesting for research. So once you've gone through these steps, you can finish your work. You have a chart that's been generated, and you can take that chart, right click on it. Oops, sorry, gotta click out of it, and then right click on the chart to export it as an image. So that's one thing you can do. And if you're going to use different images, so different charts in any given paper or presentation, one final trick is to color your chart using a consistent scheme. And one of the schemes I like to use in my own research or with my students is to paint the accurate productions in green. And in LibreOffice, you double click on the area, and then you can from there pick your color for the area. And the deletions in red, I'm just going to use a darker red just for sake of demonstration. My devoicing is already in yellow, and I could turn the other pattern into some kind of a more neutral gray. And with that organization now, we have the story of Katochia's productions of D and singleton onsets addressed within a picture. And then the next step in the research here would be to understand why we have this variation. But for the time being, the time of this technical demonstration, the idea is that, to recapitulate, the idea is that we started with a raw aggregate obtained from Phon, and from there, looking at trends in the data that are represented here quantitatively, we decided to highlight the leading trends and to combine the marginal trends within one category, and that gave us an aggregate that's a whole lot simpler to represent visually than the original one. And with that aggregate, we can tell the story of our data, in this particular case, Katochia's production of D and singleton onsets. And if we're interested in these data some more, the obvious question would be, why is she so variable in her production of a consonant considered to be both easy to produce and frequent under virtually every theory of phonology and phonological development?